So this is my first attempt at machining aluminum with the FR4. I attempted to make a short video prior to this one, but I accidentally banged the stop button here. And unfortunately, using the universal G-code sender, the way that program's set up, it just streams the commands to the machine, and hitting that stop button pretty much puts it into an unrecoverable state, or at least as far as I can tell, it's unrecoverable. I can't clear the command buffer. There's no real way for me to resume the file. So I had to go back into my G-code, and luckily Autodesk 360, or the Autodesk Fusion 360 generated G-code with absolute positioning instead of relative. So I just went in and took the G-code, looked at the line that I was at, found the first line above that had X, Y, and Z coordinates, so I knew approximately where the spindle was supposed to be. And then I just went ahead and deleted all the all of the lines between that and the initial setup. So that's where I'm at right now. I've got the spindle up at 5200 RPM, and I'm about to hit play on this. I manually moved it to the position that it was supposed to be at just to make sure it looked like it was sane. It looks like it might be just a hair above the work. I had to restart the universal G-code sender, which meant I had to rehome it and reset my work zero. So this is kind of a test of the machine's repeatability as far as its homing and everything. So it looks like it's pretty much spot on. It might be a little bit high on the Z-axis, but I'll see what happens when I hit resume here. Hopefully I won't crash the tool into the work here. But I'll go ahead and hit start and see what happens. Well, it's making contact with the work. Now this is not really an ideal setup, and I apologize for the jerky camera here. I'm just using my phone. The problem is this spindle's only set up currently with the driver to run at about 5200 RPM. Aluminum really needs a higher spindle speed. The surface feet per minute of aluminum, I think, bottom end is about 500, and the best I can do with a 1/16 of an inch tool with 5200 RPM is about 81 feet per minute. So I'm running considerably slower than I should be, and it's, I think, resulting in a bunch of chatter of the tool and some rough finish. So I think on the finishing pass it might be a little bit better, but trying to rough this out with a 1/16 of an inch tool is pretty grueling. I am relatively new to CNC, and I'm kind of using this machine to kind of get my feet wet. Most likely I'll be upgrading the spindle motor here. It's rated 8,000. I'll probably, as a first attempt at modding this thing, is reprogram the driver board that's on the back to try to spin this up closer to the rated 8,000 RPM. That might give me a little bit better performance, especially if I move to a 1/8 of an inch tool for this thing. Also, I might replace the collet here. The spindle motor is a 8mm shaft, so there are precision collets out there that will fit that 8mm shaft and allow me to fit a 1/4 inch tool. So I might go that route. If I put a 1/4 inch flat end mill on this and run it about 8,000 RPM, it should get me close to the speeds that I need to be for working aluminum. But I will post a follow-up video once I get to that point. Otherwise, I'm going to let this thing chug along here. It's probably going to take another 48 hours for it to finish this part. So I hope I will have a finished piece that I can show off and put on my 3D printer so I can replace the crappy plastic part that I have on there, which is subject to heating and bending. So aluminum should resolve that problem, since it's not going to melt at relatively low temperatures. So I'll just go ahead and wrap it up here, and hopefully in about 2 days here I'll have a finished part and put the results online. Thanks for watching.